Well, hello, calculus class. How are you? So I'm still at jury duty. Hopefully you're seeing this Wednesday. Um, so we need to keep moving. So far you've learned, without me, hopefully, function composition. That's where you put one function into another, like f of g of x, that kind of thing. And at least the definition of function inverse, which is what class? Turn and talk, say it to your partner. I'll wait here. Why, yes, it is function inverse just undoes what a function does. So if one function adds 5 to every input number, then its inverse, expressed as f to that negative 1 when you look at it, but you don't actually say negative 1, you just say f inverse, um, will subtract 5, right? Okay, so those two things. And then you also learn the big one is the point slope form of a line, right? So can you just turn and talk and see if you guys remember that one also? And then obviously you can just pause this video. There's no reason for me to actually wait live. Go ahead. Okay, so next thing to know is something called piecewise functions. Piecewise functions. So a piecewise function happens when you need to cover two or even more than two rules using the same function. So what do I mean by that? So like if we draw our function box here, bam, sometimes, and here's our input and output, sometimes you could have one rule for if x is less than 0. So let's say you'd have for, can you see this? Kind of. For x is less than 0, have this rule. F of x equals x plus 3. Okay? And then you might, for whatever reason, need another rule when the x's are not negative, greater than or equal to 0. F of x equals x plus 5. You could totally have that. That happens sometimes. Okay, so that's a piecewise function. It's in pieces. For x is less than 0, it looks like this. For x is greater than 0, it looks like this, okay? So when you graph that, well, it's a weird graph. For x is less than 0, we look for this to be the rule, right? So that's a line, right? Can you tell that's a line? Mx plus b. It looks like mx plus b where my m is a 1 and my b is a 3. So that means I have a slope of 1 and I have a y-intercept of 3. And that's only true, though. That's only true for when the x's are less than 0. For any of these x's, I look at this rule. So what does that look like when I plot all my points? Well, it's just going to look like a line that has a slope of 1 that has 3 as the y-intercept. Okay? And then after, at 0 and anything, all the x's after that, then what rule do we look at? Well, just follow the instructions. We look to this rule. So this guy is also a line, same slope, but its y-intercept is 5. So there's 5. That means that for any of these x's here, I have to look at this rule. So I'll end up with a parallel line, but not the exact same line. Now let me add some arrows. So that way, this guy has a y-intercept of 5. And this is the graph, almost. The one thing about this graph that's a little ambiguous is you can't tell what this function's value is right when x is 0. Because when x is 0, it looks to me like we could either say that it's 3, that the y value is 3, or that the y value is 5, right? So how do mathematicians indicate which of those it is? Okay, well, first of all, which one is it? Is it 3 or is it 5? Hopefully you just looked at our rule and said when x is 0, then we got to look at this guy, right? When x's are, this says x's are greater than or equal to 0, go with this rule. So do you see that when x is 0, we got to have a y value of 5? Okay, so how you indicate that on a graph is you just make a solid dot right there. And then to make it really clear that it's not here, you leave an open dot saying, no, there's nothing going on there. There's just an open dot. Go for the solid dot if you want to know the value. So now that's perfect. That's exactly the graph of this piecewise function. No ambiguity in any of the points. You know right what the y value is no matter where you're looking. Okay, there is another aspect to piecewise functions, and that's just the notation. We have the graph form, right? So what's the algebraic form look like? And do you remember I'm referring here to the 4 forms of a function. You could have verbal, algebraic, table, or graph, right? So we have the graph. The notation, if you're expressing the function algebraically, they use a curly brace, all right? So here's what this guy would look like this. So f of x equals, and then they do a curly brace, which you should get good at making sort of neatly. Doesn't have to be perfect, but sometimes they look a little bit grotesque when kids are first doing them. Anyway, you write down the rule, x plus 3, a comma, and then the x values it's good for. So this would be x less than 0. For any x is less than 0, here's the rule that you use. And then right beneath this, and so you just stack the rules one on top of each other in this curly brace. Now, we only have 2 rules, so I'm just going to have a kind of a 2-story stack here. For x's that are greater than or equal to 0, I'm going to have x plus 5, bam, bam, bam. And that's for x's greater than or equal to 0. All right, you see that then? So I make a little curly brace, and then I put one rule and the x values that rule is good for. And then underneath that, I put the next rule and the x values that that function is good for. Okay, so bam, that's piecewise functions. Can you just try one and we'll see if you get it, all right? So I'm going to give you the verbal form. So see if you can kind of remember. I'll try to just make the rules easy, okay? Okay, and then you, after I'm done with the verbal form, see if you can't put it in algebraic form and then also graph it and see if you get it, okay? Okay, so here you go. I haven't actually prepared one, so let me just think of one. Okay, I'm going to be slightly mean, all right? Let's say that our rule is just a 2-story rule like this here. And then let's say that when x is less than 0, f of x is equal to 3. When x is less than 0, f of x is equal to 3. And then when x is greater than or equal to 0, f of x equals the ln of x. Pause the video, give me the verbal and the graph form of that, please. Okay, so here's what I would get. I'm going to do the algebraic first. So it equaled 3 when x was less than 0, and it equaled the ln of x when x is greater than or equal to 0. So I think that's what I just said. Okay? And then if you need the graph form, well, it's a constant 3. When x is less than 0, oops, when x is less than 0, it's a constant 3. And then when x is greater than or 0, it's the ln of x, which everybody remembers that one, right? It plummets right there at the y-axis, and then it's a number crusher, right? Like it doesn't matter how big you get on the x's, the ln's are barely increasing at all. Now, open dot, close dot. Does this function equal 3 right at 0? No, it does not. Because which of these lines do you look at for when x is equal to, my screen just blacked out. Hopefully I'm still recording. Which of these do you look at when x is equal to 0? This line right here, so ln of x. So this guy, open dot, and that should be your answer, okay? Okay. I don't know. We could do notes, but that's kind of it. Like, I don't know. Let's just not. Piecewise functions are for when you need more than one rule for a function, and you express them like this, where here are the rules, and then here are the x values they're good for. And then open dot and close dot. Open dot means don't look here. The function doesn't equal this. Close dot means, look here. This is what the function actually equals at that x value. Sometimes, just so you know, this is not an official word, but sometimes I think of piecewise functions as handing off from one rule to another. So like here, I would say, the handoff point is at 0 because x plus 3 was carrying the load, doing the generating the y values, and then right at 0, once we get to 0, it hands the load off to x plus 5, and now this is the rule that will be generating all the y values. So if you hear me talk about a handoff point, that just is like 0 here or 0 here. That doesn't have to be 0. It could be any number. So just so you know what I mean when I say handoff. All right? Good.